Hello there. Today we're gonna build Mak Mak, which means more or less more than more in Thai. And I took the expression from the old saying in Eurorack, you can never have enough VCAs. So that's why the name. It's you can think of it as a quad channel, and each channel can be a VCA or can be an attenuator or can also be part of a 3-channel mixer, with the 4th channel being the main output. And I added just a little bit of headroom for clipping, and you have some feedback on the panel as well when it's clipping, just to add a little nice effect of saturation. Not too much, so it's not a distortion effect, but it will make round things a little bit more squarish, giving this nice little touch of saturation that I enjoy. So let's gonna build it together. I have the links in the descriptions for the GitHub, for the other videos like the demos videos that it's just audio, it's non-talking, just so you can watch and see what the model actually does. And I hope you have fun building it. Thanks for watching. See you next time. So let's get started on building our quad VCA attenuator mixer. We'll start with the control board where we solder all the main user elements. There's a couple of resistors, capacitor, but nothing big. This is an easy board. So I'll do like I always do. I start from small to big. So let's put the resistors, then the small capacitors, so on and so forth. So as always for the resistors, I always give a little touch of soldering on top, then I move to the back, cut off the legs, adjust some soldering where and if it needs to, and I will take it from there. I do the same for the diodes as well, makes it easier and faster. So now we have one IC on this control board. It's a dual op amp. We'll just connect it through the socket. I always like to use sockets. It prevented me from throwing models out of the window in the past, so I recommend you do the same. My way of soldering is just, holding on the back a little bit the IC while I solder 2 opponent legs on the board, and then once it's in position, you can just solder away the rest. So on this board we also have an LED, a red one, to give a little bit of a feedback when you're using as a mixer, for example, to give you feedback on when it's peaking, for example. We will see examples of how to use it as a mixer with the peaking, a little bit of clipping in the next videos as well, which is a cool feature. So this LED is acting as an indicator for that. We'll put it right here, because the top of the LED should be in touch, or almost, you can do it halfway between the panel itself, because the light will be reflected through the material of the panel. The panel is not aluminum, it's FR4 material, which if you open a little bit on the design, you can actually let light pass through, diffused, which I think it's great, and I've been doing for my models now. So just don't forget to add the LED here, don't solder it just yet. We're gonna add the front panel components as well now. We'll put just everything in position before soldering, and then we add the panel to make sure they are locked in position, and then it's just easier just to solder them all. For the LED, you might want to check. I think it's best not touching the front panel, just leave a little bit of space so the light can diffuse even more, from my experience, but it's quite easy. Just put everything in position, turn the board around, and then it's just soldering. So now we laid our components without soldering them. Let's just have the front panel and twist the components to make them stick in place. You don't have to push all the components. A couple of them on the extremities of the panel should be enough to hold all of them down. Then you just turn them around and solder one by one. It's quite easy to follow. Never mind this front panel here. You can see on the logo, on the spicy image, there's a little issue with the white color. Don't worry about that. This is a prototype version. The final version is already corrected this.
But I'm basically, you know, I have to take the best of what I have considering the cost. So I'm using an old panel version to do this build video and to do the demos later on. You'll get the idea of why the LED is interesting and how it works actually. But for now, you know, don't worry, this won't be in the final version for you. And there you go, we just finished this board now. We're gonna have to take the plate again because we need to connect the two PCBs before. But trust me, it's totally worth to do it this way because the components will all be soldered in the right place right from the beginning. So hopefully you can see the LED, how I solder it. I just left it at mid path between the board and the panel. I think this will do a good reflection to the panel above and let light pass through quite nicely. We'll see it in the demos, cross your fingers. I'm hoping it works quite well. So now we're gonna start with our main board. As you see, there's a lot of resistors going on here. I think it's a relatively easy build because keep in mind, these are 4 channels of identical components. It just repeats 4 times. Apart from the last channel, which is a bit special, we'll show you how in the next videos. But so you know, when you're soldering down, you're soldering one component 4 times. So if you think like this, like me, maybe it makes it easy. It makes it easier for me at least. So I'll do the same process. I always do the same. I'll add the resistors in place first, I don't know, maybe between 10-15 of them, and then solder them away, cut off the legs, do the same until all transistors are soldered, and then I just proceed from smaller to bigger, and that's about it. I just solder it away. Now I'm just going to connect the power connector. Please keep in mind this is the only component that is soldered through the back. It's in the reverse according to the other components. Just leave some space around before you solder it because it has tiny little pins on the back, but it's also an easy soldering job here. Just a little bit clean up. I don't like to leave any dust in here, and there you go, all the transistors on this beautiful geometry, if I may say so. So let's proceed to the next components now. So now we're gonna add the transistors. There's 1, 2, 3, 4, 8 of them. I'll add them all at the same time. Just be careful to leave some space between the base of the transistor and the board itself, as they are very sensitive to temperature changes. These ones I'm using a small footprint, which I'm actually not using anymore, but at the time, you know, I wanted to try, and I keep trying different kinds of footprints, different kinds of sizes, see what works best. These ones are small, so you have to be gentle on the back when soldering them. My approach is to separate the legs a little bit, give some room to solder, and be very patient and gentle. Be sure not to create any joints between the legs, but that's about it. This is about the most sensitive soldering process here. Once you do this, everything else will just run out smoothly. So I guess what I'm trying to say is just be patient, don't push it, make sure the transistors are in the right position. Yes, I failed in the past, and it's a pain in the ass to desolder these guys. Leave some room, turn around the board, open the legs, you know, give some space for all the joints to be soldered individually, and just take your time. Now I'm just gonna add these small little trimmers, very easily accessible on the top of the model. Sorry for my Portuguese pronunciation. This is basically the same, it's one for each channel. Is to adjust a little bit to compensate for any, you know, imperfections in components that we always have to account for that, so that you can make sure and calibrate to have a clean VCA, as much clean as possible. We'll go through the calibration process as well in the next video. So now it's sandwich time, and we're gonna connect the pins. First I will connect these pins here, and then I connect the female version to the pins itself, and only then after I put both of the boards together, and only at the end I will solder them down. This way, you know, in the perfect world, you solder these down and you don't have to open the model anymore, right? They're already in a good position. You know, I've been using this mechanism for all my models so far. None of them fell off the back. I'm testing with, you know, a little bit of special glues on top to make sure like they are super resistant and in any case, or maybe I'll try with some screws in the future, but for now it's working quite well. So far I never had any kind of issues with my models regarding this. There we go, almost at the end. Now for my favorite part, to add all the knobs and all the bifaco nuts, or banana nuts, or bifaco banana nuts, or whatever they call them. I basically use the black ones and the red, the black for input and the red for output, but this is totally a design decision that you can just leave the default ones, or you even use different knobs. It's up to you actually. And there we go, we have our model. You know, the symbols that you see on the panel are Thai symbols for numbers 1, 2, 3, 4 to identify the channels. And that's pretty much it. It's a quad VCA or attenuator each channel, or you can use it as a 3-channel mixer with some clipping tricks, magic tricks happening in the back. You can actually drive it a little bit, it's quite interesting. And yeah, let's put on the knobs and take them for a ride. You can see here what is my knob tool for the Davis clones. You need to give a space between the base of the pot and the base of the knob itself, otherwise it will be very clunky, it won't feel right, it will be very heavy. And yes, took me a while to figure this out. So I just created this little, I don't even know how to call it, you know, it's a little piece of wood with some duct tape that just I put beneath beneath the base of the knob, and then I soldered in that position. That way I always make sure there's space between the both components, and this way, believe me, this way they are super smooth. And then you can configure a little bit the pressure that you prefer by screwing in a little bit more or a little less. It's up to you. And there we go. You see the knobs, they are super smooth. You cannot feel smoothest through the video yet, but they are, trust me. Again, never mind this white mistake from the factory on the spicy symbol. This is not on the final version. So now let's talk about calibration. It's quite easy for this model. Remember, think of it as 4 channels. Each channel can be a VCA, can be an attenuator, or can be part of a 3-channel mixer. We're just gonna make sure, using the trimmers on the top, I'll show you how quickly. You just center the wave around 0. I'm using this oscilloscope here to measure the difference between the high and the low, the maximum and the minimum. and make sure they are centered around the middle. And then you can also decrease the volume of the channel and make sure there's no sound coming out of it when there's something connected. And that's pretty much it. We're just basically leveling our default level, which should be 0. And I'm just checking the max and the min, if it's centered around 0 as well. So that's what the trimmer does. You'll realize it quite quickly, and it's quite easy to adjust. So now you can see everything is calibrated, centered in the right position, no sound coming out when the volume is at 0. So we are ready to go. Quite simple calibration process. So let's jump finally to some demos. So thank you for watching. I hope you have fun building this model. It's quite useful, as you'll see in the demos. Remember, each channel can be a VCA, can be an attenuator, or can be part of a 3-channel mixer. The 4th channel in this use case works as an output with its own master gain, and you can actually bring it to distort it. You'll create a clipping effect, which is quite nice. So I recommend watching the next video, which is some pure audio demos, nothing of me talking, just enjoying the pleasures of the wave and the noise. And have fun. See you soon.